Okay, dear children, let us start our new chapter, that is chapter 1, real numbers. Okay, what do you mean by real numbers? What do you mean by real numbers? Real numbers are the collection of rational and irrational numbers. Rational and irrational numbers. Real numbers, the collection of rational and irrational numbers. Rational and irrational numbers. Okay, rational and irrational numbers. Then what do you mean by rational numbers? Rational numbers, yes, we can express rational numbers in the form P by Q, where P and Q are integers and Q not equal to 0. For example, 1 by 2. 1 by 2 is the form of P by Q, okay, and 1 and 2 are integers and 2 not equal to 0. Okay, then what do you mean by then what about minus 1 by 2? Yes, minus 1 by 2 also a rational number. Why? Because minus 1 and 2 are integers. Okay, then 3. Is 3 a rational number? Yes. Why? We can express 3 in the form of P by Q like this. 3 by 1. Okay, 3 and 1 are integers. Clear? Then, so that is rational numbers. Rational number we can express in the form of P by Q. Okay, P and Q are integers and Q not equal to 0. Then what do you mean by irrational numbers? For example, root 2. Root 2 also we can express like this. Okay, but root 2 and 2 should, if root 2 is a rational and root 2 and 1 should be integers, but in this case root 2 is not an integer. Okay, so root 2 is a rational number. Okay, so rational numbers. In this chapter we are going to learn some properties of rational numbers and irrational numbers. First we are going to discuss some properties of rational numbers. Okay, rational numbers means we are specifying positive integers, positive properties of positive integers. Okay, positive integers means, yes, we are not considering negative integers. Okay, so there are two properties. First one, Euclid's division algorithm. Division algorithm. And second one is fundamental theorem of arithmetic. Fundamental theorem of arithmetic. So for positive integers there are two properties. We have to learn two properties. First one, Euclid's division algorithm. This is a deleted portion and we are neglecting this portion, and directly we are going to second property, that is fundamental theorem of arithmetic. Okay, dear children, let us discuss what is fundamental theorem of arithmetic. Okay, every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Okay, this is fundamental theorem of arithmetic. Okay, to explain this theorem, we need the clarification about composite numbers and prime numbers. What do you mean by composite numbers or prime numbers? Prime numbers. What do you mean by prime numbers? Yes, for example, 2, 3, 5, 7. The 7, not 9, 11, etc. are prime numbers. Primes. And composite 4, 6, then 9, 12, etc. are composite numbers. Composite. What are the difference? Yes, prime numbers have only two factors. Okay, for 2, 1 and 2 factors. 3, 1, 3. 5, 1 and 5. Only two factors. For composite numbers, more than two factors. That means for 4, 1, 2 and 4 are factors. That means more than two factors. Okay, then 6. 1, 2, 3 and 6. So that is the difference between composite numbers and prime numbers. Okay, let's come back to our theorem. What is the theorem? Fundamental theorem of arithmetic says that every composite number can be expressed as a product of primes. Every composite number can be expressed as a product of primes. Okay, for example, 140. 140. We can express this 140 as the product of its prime factors. Let us check. Okay, let's factorize this 140 by using its prime factors only. Okay, 140. 10. 10. 10 is possible or not? No. Why? 10 is not a prime number. It's composite number. So don't factorize 140 with it by 10. Okay. Use prime factors only. So 2. You can start with 2. 270. Okay. Then again 235. So 2. Next step 2 is not possible. So take 5 or 7. Okay. We can go in increasing order. 5. So 7. So 140 is a composite number, and we can express this 140 as the product of its primes. 2 into 2 into 5 into 7. Okay, 2 into 2 into 5 into 7. All these numbers are prime numbers. Okay, so we can express this composite number 140 as the product of its prime factors only. Okay, don't use composite factors. Okay, so this is the first sentence. Every composite number can be expressed as a product of primes, and this factorization is unique. What do you mean by that one? Yes. See, to express 140, we can use only these 4 factors, prime factors. We cannot use any other prime factors. Okay, only these 2 factors. Okay. Then this factorization is unique. That means to express this composite number, only these factors we are using. Okay, we cannot use 13 or any other number, or we cannot avoid any number here. 2, 2, 5, 7. Okay, these 4 factors we are using, prime factors we are using to express this composite number 140. Okay, so second sentence also clear. Then apart from the order in which the prime factors occur, order may be changed. That means if we factorize this 140 like this, first 7, then 20, okay, then 2, 10, then again 2, then 5. So this order is 140 is equal to what? 7 into 2 into 2 into 5. Factors are same, right? 2 2's are there, then 1 7 and 1 5. Okay, but here order is 2 2 5 7, but here order is changed 7 2 2 5. Okay, so fundamental theorem says that every composite number can be expressed as a product of primes, and this factorization is unique. Okay, factorization is unique. 2 2 5 7 here also. If we do any type of factorization, okay, we will get these 4 primes only. Okay, and order may be changed. Okay, here 2 2 5 7, here 7 2 2 5. Okay, this is fundamental theorem of arithmetic. Clear? Okay friends, let's discuss one problem regarding fundamental theorem of arithmetic. Okay, I will read the question. Express the number 306 as a product of its prime factors. Okay, so we have to express this composite number. Yes, this 306 is a composite number. Okay, and we have to express this composite number as the product of its prime factors. So we need first to factorize this 306. Okay, 306 factorization. Okay, 2, then 1 time, then in 10, 5 times, 6, 3 times. Okay, 2 is not, next step 2 is not possible, so take 3. 3 also a prime number. Okay, 15, 5 times, 1 time. In 51 again 3, 1 time 21, 7 times. Okay, 17. Okay, so we can express this composite number 306 as product of these prime factors. Which are the prime factors? 2 into 3 into 3 into 17. 17 also a prime number. Okay, so we can do this in another method, that is factor tree. You already learned a factor tree in earlier classes. So factor tree means factor tree. That means 306. Okay, 306. Then 306 means 2 into 153. 2 into 153. Okay. Then 153 means 3 into 51. 3 into 51. Then 51 means 3 into 17. Okay, so 306 means 2 into 153. Then 153 means 3 into 51. 51 means 3 into 17. This is factor tree. Okay. So factor tree also important. This is the method how to express the number, any number, as a product of prime factors. Okay.